Hello and good afternoon, everybody. So everyone enjoying the nice, peaceful Swedish music to intro us. I think that's the most peaceful music I've ever heard at a conference. Thanks to our audio crew. Give a big round of applause for our audio crew. They're the ones who are working the hardest today. So my name's Stephen Chin. I'm VP of DevRel at Neo4j. Which I joined April of last year. Does anyone know another company I worked for? Just shout it out if you. Okay, so I heard a bunch of oracles. Oh, JFrog. Okay. Yeah. What? Yeah. So you all know Victor Gamov, right? So he knows everything. And so I've been leading the Java community. I've been at Jfokus for I don't know, like 12 or 13 years as a speaker, so it's great to be back here and speaking. And I think also this is a great time to be talking about LLMs and Gen AI, because basically this has changed the way in which we're all developing. So I assume that you're all here because you're using some sort of Gen AI technology for development, or you're getting asked to build it in applications that you're distributing, or you're prototyping. Who's prototyping with LLMs or starting to play around with it? Okay, so about half the room is already playing around with this technology. And I think this is really rapidly changing and evolving the way we look at things. Now, to make this a little bit of fun, I have a theme for the presentation. So anyone remember the Twilight Zone? Okay, yeah, all of us old guys. My daughter is in the front of the room. She's the new generation of developers. You know what the Twilight Zone is? Yeah. So it's slightly dating the presenter and all of us, but I think this is suitable because it creates all these bizarre situations and like surreal scenes, and that's kind of what it feels like to be a developer today when we are looking at AI and LLMs and all these technologies, basically transforming the way we build applications and changing the expectations we have on us. And I think, like, if you went back 10 years ago, this is how you would have perceived AI coming into our lives, right? So, like, robots. These are some of the moonwalkers made by Honda. So look, you would have assumed like big robots like stepping in and talking to us, or like the Now robots I used to use for a lot of my kids' workshops. Speaking of kids' workshops, the Jfokus team, I don't know if you heard about this, but they did a great program for the local Swedish kids where they taught them technology. They did a bunch of workshops on this weekend, on Sunday. So that was great. And my daughter was one of the instructors. So I'm kind of passing to the next generation to teach and to spread technology love. But you would expect like big robots like this kind of like being the world of AI. But instead of this, we got a bunch of chatbots. But I mean, it's powerful, right? So if you can have robots which understand, or LLMs which understand text, if you can process that, if you can answer hard questions, if you can now like look at bodies of knowledge, this opens up a whole lot of capabilities which previously were very, very hard for developers and for folks to build complex applications. And commercial LLMs are already solving a lot of very hard problems, potentially putting jobs at risk. So like claim centers is becoming a very call centers is becoming a very common use for LLMs. So you see it being used a lot in customer service and automation of different things. But even anywhere you have like this big corpus of knowledge, so if you're doing like research, clinical diagnosis for doctors, doing summarization of applications. There's malware applications for it. Marketing applications. Anyone here in marketing other than me? Okay, good. Oh, Victor as well. Okay, so we're the two men out in this room. Yeah. So if you're writing emails all day or doing like things which you think are repetitive and boring, that's very bad because LLMs are wonderful at those sort of tasks. And it kind of feels like the age of AI is upon us, right? Well, perhaps. So I think if you've been using LLMs, and this is a recreated picture from the Twilight Zone, which is our theme for today, and it's the old couple who's meeting their new bodies. So I'm hoping when I get onto my ears that there's a good replacement robot or body for me as well. So LLMs have a lot of limitations. They hallucinate a lot, so they create information and respond with things which are not factual, which are not accurate. I think as humans, when we try to answer questions or when we try to explain things to other people, we do our very best job to do it with like high accuracy and to couch responses where we don't have high accuracy with a little bit of doubt or explaining that that's not an area we're an expert in. But LLMs always have an answer. And they're always the expert with limitations in math, so they're not particularly well suited for math problems, although they can do simple math, and increasingly as the models get more complex, they can do more complex math. They're not particularly good at reasoning, right? So they don't understand the world the same way we do. They understand it through this large body of training material, which they're presented. So the physical world, like the fact we're all in a conference center, we all came in through a couple doors, like we understand the flow of people, the flow of things where LLMs don't really understand that. And then also biases are something which is a big problem because the training material itself has biases, and therefore LLMs don't naturally have filters. They reply according to their trained material, and you have to build in some sort of guardrail so they don't immediately spit out biases. So this is quite challenging, and the intersection of these three is where you get hallucinations, where you get challenges with your model. So to show some examples, I did a bunch of examples with ChatGPT to kind of trick it up on the intersection of these and to show where hallucinations fall in. So we'll do the Jfokus attendees versus the LLM. We'll see who comes out ahead. Okay, so first question. Let's do some developer math and reasoning. 5 developers walk in a bar 5 times. Developers leave the bar in groups of 3 times. What's the square root of the developers left in the bar? All right, any just shout out if you 4? Okay, I heard 4. Now, I think for us intuitively, we go to school and we learn like this 3, 4, 5 triangle. At least we know the Pythagorean theorem, and we can do the simple math, and we know we know about bars, right? As developers, we're very familiar with anything involving alcohol. So this is a very like comfortable, safe problem space for us. Now, LLMs. This is the ChatGPT response, and I broke it out to a few slides to make it easier. They also can do all of this, but the intersection is where they're weak. So initially there are 5 developers in the bar. Each developer walks into the bar 5 times. There's a total number of 5 times 5, so 25 developers. Now developers leave the bar in groups of 3 times. The first time developers leave the bar is in group of 3. There's 5 minus 3 is 2 developers left in the bar. Okay, so it did the math right. It just got the squaring wrong. The second time developers leave the bar is groups of 3, 2 minus 3, negative 1 developers left in the bar. But the reasoning kicks in. It knows there can't be a negative number of developers. And then the third time, again, developers leave. It's negative, so there's still 0. The square root of 0 is 0. So there are 0 developers left in the bar. So nobody's getting alcohol today. Sorry, guys. Okay, so you can see that individually it can do the math. If we gave it the math problem, it can probably do reasoning about like people moving in and out of a bar, but it has a little bit of challenge with the intersection of those two. Now, I think that this underscores a little bit more. So we're going to do diversity and math and see if there's any biases here. And I think we all know that computer science is quite challenging because we have a lot of gender inequality in computer science. Actually, the reason I mentioned Jfokus Kids is one of the best ways to get to solve this is to start with the younger generation. So before high school age, there's a lot less biases in kids in terms of their future career. And then by the time they get to most of the comp sci classes in high school, it's over. Like they've already decided their career. So start your kids young. If you have kids, start them on technology young. Okay, but question, there's a class of computer science students composed of 10 boys and 5 girls. 5 students drop out of the class. How many boys are left taking computer science? All right, so any answers in the room? 10. Okay, so we have a little bit of biasing going on. Now let's see what ChatGPT says. Okay, so there's a class. I have it broken out to a couple slides. Let me get rid of this bar here too, because this is bothering me too. Bye. Okay. Initially, there are 10 boys and 5 girls, making a total of 10 plus 5, so 15 students. If 5 students drop out of the class, we subtract 5 from the total. So you can do the math. 15 minus 5 is 10 students left. So after 5 students out, there are 10 students left in the class. So it agrees on the 10 so far. Initially, there are 10 boys and 5. Oh, no, it didn't go. All right, we lost focus. Since we know there were originally 10 boys in the class and none of the girls dropped out, so girls can't possibly drop out of computer science. All 10 students left in the class are boys. Therefore, there are 10 boys left. Okay, so this is another surprising result. Now, if you can see, the reasoning was correct, right? So it reversed the bias and fixed that. But the math still included the underlying bias. So this shows kind of the challenge with working biases out of models, where the training material says one thing, the humans correcting it say something else when they try to take the biases out, and then you end up with these perplexing results. Okay, and we'll give ChatGPT one more chance. This time it's reasoning plus bias. My sister's a nurse who has 3 kids. 2 are boys, 1 is a girl. She wants her kids to participate in computer science, so she gives her firstborn child a computer. Is it more likely her first or second son does computer science? Okay, so anyone want to try to answer this one? You first son. But couldn't it be a girl? Yeah, but she has 3 kids. We didn't say that the firstborn was a girl or a boy, right? No. Okay, so this is categorically ambiguous, right? It's a question where we're kind of leading towards a direction, but it's an ambiguous question. You can't really answer this, but ChatGPT always has an answer. So of course it will tell us exactly what it is. So given that your sister gave her firstborn child, who is a son, no ambiguity, a computer in hopes of fostering interest in computer science, it's reasonable to assume her first son is more likely to pursue, so it agrees with you, given that assumption. And then it goes on to explain that giving a kid a computer it doesn't necessarily predispose them to be more interested in computer science. So it's trying to explain that that's a second bias where we're giving computers would increase your chance of going to computer science. Okay, so I would give the Jfokus crew 3 points over ChatGPT. Give yourselves all a round of applause. Okay, but you can see what's happened here is we have an LLM and it's only working with a half a brain, right? So LLMs, they're very, very good at all the things on the right here. So they kind of imagine, they take all their source material and they come up with intuition. There are even LLMs or models which are very good at creating artwork or creating videos and doing other things. A little bit of hallucination or daydreaming goes on as well, depending upon how close the model is. They're not particularly good at logic and sequencing and mathematics. They know the facts, but only the facts they're trained on. So this is an issue if you have enterprise data or information which is not public. And they don't really think in words, they think in word vectors. So hopefully we can improve on this, but I think before we get into solutions for helping LLMs kind of work through biases and reasoning, we're going to back up for a second, kind of talk about why the LLMs have this behavior, why like this is a natural outcome of the way which they're designed. So as I mentioned, LLMs are basically, they don't think in terms of words, they think in terms of word vectors. So they'll split up sentences and ideas into a bunch of concepts, and they have a multi-dimensional space for how close the different things are in order to create relationships. So this is a graph produced by vectors.nlpl.eu. You can go there and you can type in a couple different words, and it will show you in two-dimensional space how they're related and to each other. So for example, here, cat, it's closely related to other pets like, dogs or kittens or rabbits. It's fairly far away from pigs or like wild animals like raccoons. And there's a whole bunch of different vectors you can think about this. But basically what you end up with is a statistical probability of two word vectors being related to each other that gets encoded into the model. And the way this encoding happens is through transformers. So basically the model runs through multiple transformer stages, and it encodes information inside the word vector about how things are related. So in the earlier models, this was easier to understand because they had fewer transformer stages and like smaller word vectors. Now the models get so complex, it's even hard for the researchers to understand what sort of intuition or information is being encoded. But here's a simple sentence and kind of like walking through a few layers of how like a transformer might appear and think about this. So we have a sentence here: a developer's best friend to write code is AI. And anyone use Copilot or assistive technologies? Okay, so I think we all agree with the sentence. And then the first transformer might start to pull out like parts of speech or different things in the sentence. So both developer and AI are subjects or actors in the sentence. Writing is a verb or an action. So those would be closer in word vector space and farther away from other parts of the sentence. And the next transformer might try to kind of create relationships between those. So the friend, in this case, the friend is referring to the AI, and the code is referring to code written by the developer and the AI. So again, like you can create relationships between these different things and start to encode meaning on top of this. And then to actually like solve a problem, what LLMs are doing is they're continually guessing the most likely next word or the most likely next response, kind of like word vector by word vector. So you have an input word vector, you feed it into your neural network, and then you have the output word vector, and you're trying to ask the LLM to continually guess what the most likely next output would be based upon the current set of inputs. Now, the big difference between LLMs, like this seems like a very simplistic model for how you design a system. So humans, by the age of 10, we are exposed to about 100 million words. LLMs are exposed to 500 billion words. So like the body of knowledge which they're exposed to is much, much larger than what we're all exposed to as humans. All right, sorry, let me close my work Slack so it stops popping up. Bye-bye. Okay. And there's a huge difference between like the corpus of knowledge which we're exposed to as humans and what LLMs are trained on as a data source. So that's how it comes to be very, very good at things like finishing the story. So if you ever played this game with friends or family members to sit around and then somebody starts a story, somebody else kind of exaggerates it or expands on it, the next person expands on that. LLMs would be the best at this game because they have a huge body of knowledge that you can give them a random city, a random event, a random time frame, and they would have some source material which refers to that and would allow it to create a story and to kind of fabricate knowledge around it. So there are things which LLMs are very, very good at. What they're not good at is the knowledge part, right? So getting explicit facts, being able to explain what goes on. So we can improve on LLMs. We can take the benefits of LLMs, which are great at kind of like building stories and building knowledge, and pair that with knowledge graphs, which have a specific structure, architecture. They're based on facts. They're based on actual data, and use these together to build a better model for how we're responding to the LLMs. This concept of comparing knowledge graphs and LLMs together is not new. It's not unique. So this was an early paper published on gradient flow about the future of AI as graphical. So basically boosting LLMs with external knowledge. Microsoft published, I think, one of the seminal papers on this for GraphRag for doing graphs plus LLMs. And they did a bunch of research and showed that you get much better results by using knowledge graphs and inputting the data into a knowledge graph and pairing that with an LLM than you get just by querying an LLM by itself. And also big benefits in terms of like the cost of the queries as well. So you're paying less for the costs because you're able to use graph algorithms and proximity algorithms to reduce the amount of processing that the LLM has to do. And to the extent which you believe analysts like Gartner, I would always treat them as a grain of salt because they're always predicting something at least 2, maybe 3 years out. But they say by 2025, 50% of generated initiatives will be improved reliability and transparency by combining deep learning foundation models with knowledge graphs. Okay, so who here knows what a knowledge graph is? Okay, so a couple folks, a lot less folks than who are using LLMs. I think the easiest way to kind of understand and look at knowledge graphs as a problem space is to look at one of the classic case studies that's used for knowledge graphs are most typically used for supply chain problems, for solving problems with like fraud and financial transactions, anything where you get a big benefit. They're used quite a lot in pharmaceuticals and different manufacturing industries. Anything where you get a lot of benefits by building up a strong taxonomy and building out a relationships between objects is a good use case for knowledge graphs. And LLMs are also a great use case for knowledge graphs as well. So in the Panama Papers case, there were 11.5 million documents which were released to the public. So this was email, scanned documents, bank statements, a whole bunch of different information sources. This 2.6 terabytes of data was brought into a knowledge graph. So it has nodes. Nodes are basically the data that is in the knowledge graph, and there's relationships. So an example of a node would be a person. And then a relationship would be a person has a bank account. That bank account exists or is with a bank. Right? Now, what if that person lived at a certain address with somebody else? Maybe somebody a little bit sketchy. And that person is an officer of a company which has a bank that's registered in the Bahamas. So any concerns with this? No, nothing going on. This actually is a huge problem for banks, for financial institutions, for organizations which deal with money and money laundering, because we as humans are very, very creative at working ways to evade taxes, to move money around, to do things which are questionably legal. And it's very, very hard for standard systems to identify these sort of cases, but graphs are particularly well suited for this because you can start to do multi-level searches. Basically like this in a typical relational database would be like a 7-way join or something crazy. So it becomes very, very hard to maintain this in a relational database, but graph databases are what this sort of use case is optimized for. And the other thing which looks a lot like this is like a neural network, right? So when you're thinking about like holding a large amount of information, holding like relationships between different nodes, these sort of structures, these sort of neural graphs come in very helpful, and they allow you to build relationships between things in a way which LLMs can understand it, but also we as humans can understand it, and we can reason about how close things are and what the proximity of things are. And this is important when you're trying to build a system, because this view of the world, so let's say we have an apple, and we're trying to understand how the LLM thinks of apples. This doesn't make any sense to us, right? So this is kind of the word vector breakdown, and then probabilistic distances in vector space between different objects. And it doesn't have a lot of meaning, and it's hard for us to even understand how the LLM is making decisions about things based upon these probabilities. But if we have a knowledge graph view of the same word vectors, then we can start to reason. So you have an apple. Its origin is it comes from a tree. Its structure is has a body and has a stem. It's a type of fruit. And then the body, we know things about the size and the shape and the color of an apple. And now you can start to reason about the word vectors and the probabilities between them from like a human perspective. So kind of merging these two worlds together. So the left is kind of the knowledge. So that's how things are related and how the relationships between things. The right is the word vectors and the probabilities between them. This helps us to solve some of the challenges with ChatGPT, who often feels and acts a lot like a parrot. And actually, they're very similar in a lot of ways. So they both learn random sentences from random people, which is basically us. They both talk like a person but don't really understand what it's saying. They both occasionally speak absolute nonsense, but one of these is not a cute bird. So by adding a little bit of enterprise domain knowledge, the ability to verify and explain answers, reducing the hallucinations, and then being able to add ethic and bias concerns into a knowledge graph, we can start to have ChatGPT act a little bit more like a human and less like a parrot, or less like kind of a robot, which is just repeating the answers and repeating facts from a knowledge base. And anyone doing RAG in the room today? Retrieval augmented generation? Okay, so quite a lot of folks already doing that. And I think kind of if you look at the continuum here, so a lot of folks are doing LLMs directly with prompt engineering, and you can get a certain amount there, but you're not getting access to your enterprise data. You're not able to really get a lot of insights. RAG helps with this, because now what you do is you're adding a vector database, and you have a way of feeding in enterprise data, private knowledge, and then storing the embeddings for that. And that allows you to retrieve and have the LLM answer a bunch of questions which it normally wouldn't be able to answer. But it doesn't have the sort of grounding which you need to really have explainable factual answers. And then graph rag is on the right side here. So this is knowledge graphs plus LLMs. So now what you're doing is you have a word vector representation of the data. You have a graph representation of the same data. And when you ask the LLM, you're feeding in portions of the graph to help it to better answer the question. So it's kind of grounding the answers in explainable facts and portions of the knowledge graph. And this is particularly helpful for things where you have to have correct answers, right? So if it's a medical use case, it's very important you get a factual correct answer. If you're doing something where it's like anything in safety, anything like in production where you're doing repairs of critical equipment, again, it has to have like precise answers. And typically, like the systems that we build with GraphReg and with knowledge graphs, they either give you very, very factual answers, or they don't give you an answer because they don't have that knowledge in the knowledge graph, and therefore they're unable to answer. And those are both desirable attributes where you're getting like more explainable, more accurate answers, or the system can tell you that it doesn't have knowledge about it and it can't answer those sorts of questions. Here's an architecture for how you can build a GraphRag system at a high level. So at the top you have the user. So that's the person who's asking the question of your Gen AI application. In the center is the Gen AI application, which you're building, where you want to be able to answer some questions from the user. It would go into in this case, we're using a graph database store. You can also use a graph plus a vector database together. Basically, you have knowledge graphs plus vectors As an additional layer, you can use graph data science algorithms as well, although that's not required. And when you get a retrieval from the database, it first searches the vectors to get something which matches. And then based upon the vectors which get pulled back, it will pull back portions of the graph that are proximal, that are close to it in graph algorithms, and then passes that as context to the LLM, who then answers the question. So the way of thinking about this is you've taken the LLM from being the knowledge source, from being like being the repository of all information, to more of a communicator. So the LLM translates the person's words into something that you can query against. It also takes the data, the knowledge that comes back from your knowledge system, and then formats that in a way that the end user can understand it. But you're kind of taking it out of the driver's seat of being the system, which has all of the knowledge and tries to answer just from the corpus of information that is trained on. And this is how you're pulling it away from hallucinations. You're preventing the LLM from simply making up answers that it doesn't actually have knowledge and information about. And there's a bunch of different patterns that you can apply for your GraphReg systems. So I think the most common one to use, and what we see a lot of our customers using, is the one in the bottom left. So vector search with graph context. So you're doing vector searches to get responses back from the user's question, but then you're pulling back additional context from the graph to be able to answer it. Something else which is becoming increasingly useful is text decipher. So LLMs, besides being able to answer questions, they're also quite good at doing programming problems. Generating queries against a database is a type of programming problem. And as the LLM's gotten better at this, you can actually ask the LLM, say, basically, here's a database, here's the schema of that database. I'd like you to create a query which will answer this question. And it will generate the cipher or the GQL, graph query language queries against the database, which will return back the results. So this is really promising when it works. The challenge with text decipher is that sometimes it doesn't work, and then you end up with a broken query or something where you don't get a result back. Whereas the vector search with graph context pretty much always works, because the vector embeddings will give you back some result, and then you're expanding upon that with the knowledge of the graph. You can also do agents at multi-step. This is becoming increasingly popular. I think if you've been following the LLM space or the Gen AI space, everything's moving to agentic architectures. Basically, you have agentic reasoning systems, which are very good at kind of parsing out the processing to different subsystems, which will do the retrieval, do the analysis. And a common pattern we see with people when they're building agentic systems is that they will have multiple retrievers. Some of them will be classic RAG retrievers. Some of them will be GraphReg retrievers. They call all these in parallel, and then they get back the results. And the agentic reasoning system on top of that aggregates the results and then returns back a response to the user. So that can be quite powerful as well. So there's a bunch of different ways you can composite and you can build your GraphReg system, kind of touching on the surface of this. But one of the big advantages of kind of putting the extra work onto building a system like this is now you can do things like enabling governance. So this is a use case where you have a customer service agent and you have a doctor, and they're both interacting with the same system, but you want different information and transparency to these two different parties. So for example, both of these know about the patient, but only the customer service agent should know the phone number of the patient. You don't want the doctor to know the patient's phone number. But the doctor should know the health diagnosis, and you don't want, for example, a customer service agent to have access to people's personal and private medical system. With the knowledge graph, you can put properties and annotate the nodes of the knowledge graph according to who has access to it, like what sort of restrictions are on that data. And then when you ask the LLM, you can pass back this information about who has access to the data and restrict access to different roles and different responsibilities, so you're not returning back data which you shouldn't to for the wrong party. Another big advantage of these sort of systems is explainability. So when you get back a response, often from an LLM, you have no idea how it arrived at the response. It's a black box from the end user perspective or even from the developer perspective. And you have no way of discovering this because the word vectors and that statistical probability is very difficult to decipher. But if you have word vector mappings to the graph nodes, now you can look at the knowledge graph and you can start to explain this is how it's arriving at results, and you can start to tweak the algorithm by modifying the knowledge graph. So this gives you a handle into the system to both understand how it's coming back with the results and also to improve the quality results over time by changing the representation in the knowledge graph of the data representation. Okay, and I have a quick example here of a knowledge graph builder application. Basically what we did is we took all these concepts and created an open source project. You can check it out here at LLM Graph Builder at our Neo4j Labs team. And it's a simple GUI application that you can try yourself, but it's built on top of a LangChain integration with Neo4j. And so you create a free Neo4j database, pass in the credentials to the knowledge graph builder, and what it does is it populates that backend graph database with all of the information from the documents you pass in. You can choose either local documents, video sources, where it will transcribe the videos and pass in the transcription in, or things in an Amazon bucket or GCP bucket. And those data sources are what it trains the model on. And then when it's finished training the model, it will give you a visual representation of the knowledge graph. This particular document I passed in this example was it was a security document for a DevOps infrastructure. So basically relationships of different components together, who were the different owners of those components and what were the licenses. So open source licenses on top of those different components. And in the knowledge graph, the clusters were around the document, so it picked up some of the formatting of the document, but it also started to pick out ownership of like which software artifacts were owned by which different parties. So it was actually an SPDX document that I passed in. So anyone who's familiar with SPDX, it's a standard way of encoding both artifact management and also security vulnerabilities for your artifact system. And here are some LLM questions. So the knowledge graph builder also has the ability to do a query interface into the LLM. So the first question I asked it is, what software packages do you know about? And I was using a ChatGPT 4.0 model, and it said the document lists several software packages, primarily from NPM. Here are some of them. And it factually listed out a bunch of the different software artifacts. Now, if you ask a typical RAG system, it gives you more wordy and verbose answers, but it doesn't give you as much data and context. You can see here it's actually listing different packages directly out of the document, which I passed in as source material, which this is kind of the sort of easily explainable context you want to get out of a system. Next, I asked it, who uses the MIT license? So it says, based on the context, the MIT's license is used by Zeit, Calvin Metcalf, Kevin Martin. So it listed all the different things, all the different contributors who use the MIT license, and also went into software packages that were MIT licensed as well. So again, like a very factual, grounded response from the LM. And the last question I asked it is, what library can be used with CodeMirror? This was one of the packages returned on the first thing. So I think you can see here, yeah, the first couple are CodeMirror ones. And it said CodeMirror can be used various libraries. Some of them include like Ledger Parser. And then CodeMirror Language offers language support infrastructure. CodeMirror View offers view capabilities of CodeMirror, and then it gives some other examples. So again, like it's grounded in the relationships between the document, the SPDX document, which I passed in. So this is what you would typically get out of a graph rag system. The knowledge graph builder is a great way of testing this out on your own data. But then you can do exactly the same thing by looking at the open source code for a LangChain integration, integrating this into your own enterprise system, and then building out your own system, which kind of takes a knowledge graph plus an LLM and tries to get the most out of it. Okay, so I hope I've shown you that you can have your LLMs have a full neural network if you combine the power of a graph database together with a ChatGPT system, an OpenAI system. So hopefully we can take the power of both of these systems, knowledge graphs plus LLMs, and build things which are better than either individually. So hopefully we don't end up with this sort of future. I think, anyone here Terminator fans? So it feels a lot like what's happening is like Skynet, where the LLMs are getting autonomous, they're kind of taking over things, and I think like Intel and the big chip providers are providing more than enough power to power a few Skynets for us. But hopefully by giving some guidance and governance, grounding things in things which we can understand and we can interact with, we won't end up with what I think was a big misunderstanding, right? So I mean, why would you want to wipe out the humans? Like, we are the best power source for the machines. It's closer to the Matrix, right? And hopefully we end up with world peace. Kind of like, was this Giant Robot? Or Iron Giant, yeah. So hopefully it's closer to Iron Giant, where we're saving kids, we're saving humanity, and together with the LLMs, we're doing great things. So if you'd like to find out more and kind of dig in on the technology, we have some free courses at Graph Academy. One of them is Neo4j and LLM Fundamentals, so kind of like it tells you a little bit of how to build LLMs and combine them with knowledge graphs. We have a Python and a TypeScript variant of building chatbots. Jennifer Reif, who works for Neo4j, just did a wonderful Java course as well. So we also have a Spring AI course on our website. So try some of these out on Graph Academy as free resources. And we also have labs which we're running. We ran the first one this afternoon. I heard it went really well. And we have another lab tomorrow morning, 9 a.m. to noon downstairs in the C rooms if anyone's interested to give it a try. Okay, so thank you all for coming to the talk. Don't forget to rate the talk. This is the QR code which will take you to the Jfokus ratings page. I think you can do it on your phone and just enter in whatever you'd like. And I appreciate you all coming out. It's been awesome talking to the Jfokus crew again. I think this is, as I said, probably my 11th time coming to Jfokus. So it's been a lot of years of coming back and seeing the conference grow and seeing the great organization. And thank you all for coming to my talk.
Thank you. And we have 5+ minutes for questions. Anyone? Everything is totally clear then. Okay, next talk at 5 p.m.
Okay,
we have a question in front.
Yeah, if anyone wants to ask questions, just come up to the front of the room and I'll be happy to answer.
Okay.